I don't want to scold you in this video, but maybe I can help you out a little bit. At least I hope I can. John Lennon wrote a song about 45 years ago called Whatever Gets You Through the Night, which is a phrase that has been popping around in the English language since the early 1960s. It's associated with a televangelist, actually. But the idea is, in the dark of the night when you're worried about everything, do whatever it takes to make yourself okay. I think what a lot of people are doing right now is looking at the really sparse understanding that we have of COVID-19 and saying things like, "Oh, I'm young. COVID-19 is not a threat to me. That's mostly something that happens to old people." I'm not going to tell you what to do to get yourself through the night, but I'd like to encourage you not to think that way. And I'll show you why. And I'd absolutely love it if you could use the rational part of your brain to not say that to others and not spread that thought around and discourage the people that you may hear it from, because it probably isn't true, and it is very likely to be a case of something called Simpson's paradox, which is kind of one of the things that can go wrong when you omit variables from a regression. So we don't have solid data on this so far, so I generated some fake data to show you how this actually works. And so here's my spreadsheet. Um, I will post this to Canvas shortly. I also found a really easy article on Simpson's paradox that I'll post to the class blog, or maybe to Canvas. I'm not sure. I'll put it somewhere where you can find it. So what I did is I generated some fake data, okay? And that fake data causes a probability of dying Y, okay, due to this fake illness, okay? So you can see here that, a young person does not have a high probability of dying, while an older person does have a much higher probability of dying. Okay? And the thing is, in my fake data, that probability is caused by both your age, but also the prevalence of some variable x over here. Now, x could be any number of things that we know are likely to lead to problems with viral infections. Um, And some of them would be things like depressed immune system, autoimmune diseases, asthma, smoking, age, okay, and other things like that. I'd like to add on here anything that's likely to get you in an intensive care unit. So this could also be things like, ooh, have to mention it because you're young people, but people 15 to 25 are much more inclined to suicide than others. So, not encouraging that in any way, shape, or form, but think about it. If you know somebody that might make a suicide attempt, they might need an ICU unit, and the ICU units are going to be really full in a couple weeks. So, that makes suicide attempts that much more threatening at this point in time. But also, you could put in things like car crashes, or again, for those of you that are in your 20s and are married, problem pregnancies, with things like elevated blood pressure and whatnot, okay, that occasionally lead to ICU trips, okay? So that's what X is, and all the math is worked out here, okay, and you can look through it on your own. Now, you guys are nerds, right? Can we be honest about that? We all are. People who are not like us form mental models of how the data actually works. And their mental models can work just fine in some situations. But what I want to do is approximate a mental model with a naive regression, which I do over here. And in this one, what I do is a simple regression of my 6 observations just on age. Okay? Um, it's a nice fitting regression, has a fairly high R squared. I do put a comment down here that it doesn't have enough observations for the variable to be statistically significant, but my main goal here was to make these purple and green tables easy for you to eyeball and figure out, and I did that by making them short and sweet. If we had a real data set with dozens or hundreds of observations in here, it would be pretty easy to get a high t statistic and a low p-value on these things. So I think you can just safely disregard this. This is made up data, okay? But here's what people do with their mental models, okay? They have this mental model that includes just age, okay? And then they use this to form fitted variables like they do over here, and they say, oh, there's a much, much higher risk of dying from this disease when you're 80. And mental models are not really terribly solid. They can work sometimes, but not every time. Now, a better regression would include every single independent or explanatory variable that you thought was important and had data on. And in this case, that's just two, so I need to include both age and X. Well, when I do include those, I find out that they're both highly significant, but I also get a correct estimate that the effective age is much, much smaller, okay, than the effect of X. And here, I just put together the fitted values again, and I used goal seek to actually say, who's at the same level of risk? A 20-year-old with the condition or somebody of an uncertain age without the condition? And what you find out here is that a 20-year-old person with that confounding condition is just as likely to die as somebody who's 70 and a half but does not have that confounding condition. So not going to name names here, okay, but think about the people that you know around the School of Business at SUU. Think about the young people your age that you know of who actually do have a health problem. We've got several around the college that have very serious ones. And think about the professors who you know are quite old and really are awfully healthy. Okay, not saying that's all of them, but we've got some pretty old ones that are pretty healthy, and you know who they are. Okay, so think about that. Okay, a 20-year-old with a problem could be in just as bad shape as a 70-year-old person who's had a fairly healthy lifestyle. Okay. All right, so down here I'm going to use a phrase that I have talked about a little bit in class because this did come up about 3 weeks ago in talking with some of the students around. Okay, when we do this sort of mental model, people are using just age as the independent variable, and they're saying something like, "Ooh, SARS-CoV-2 is not a real threat to the young." Okay, we would never say something like that about cancer, or about automobile crashes, or about falling down stairs or something like that. All of those things are more dangerous to the old, okay? But that doesn't mean you're going to say, I'm not scared of getting cancer, or I'm not scared of falling down the stairs on my head, or I'm not scared of any other sort of condition that is more likely to take out the old. Okay, the simple fact is old people are more likely to have all of these confounding factors all the time, even when they're particularly healthy. And what you're observing when you say the young are at less risk is that the young tend to have less of these confounding factors. But if they don't, they're just as much at risk. Okay? So, this is an example of something called Simpson's paradox. It's usually explained in books or the internet as a way that you can get perverse results. This is not a case where you get a perverse result, but maybe a misleading or misaccentuated result. So maybe, there ought to be like a Simpson's paradox major and Simpson's paradox minor, and this is the minor one. But it's still a serious possibility that people are fooling themselves about the risk to young people. So, whatever gets you through the night. Okay? If it helps you to tell yourself that young people are less at risk, that's fine. Don't push that idea on others, and don't spread it around too much, because it might not end up being true, and it probably is nowhere near as true as anybody thinks that it is. Well, that was kind of a downer, but figured I needed to get that out to you. Okay, I will see you in the next video. Bye.